students. Today's agenda is to check homework. We'll be learning about the slope-intercept once again, and you'll be able to work on page 11. Today, students will be able to graph equations with slope-intercept by manipulating the equation. Okay, so in the previous lesson, we learned to graph with the slope-intercept. With the slope-intercept form. And that's when y is isolated, meaning that y is by itself. What does that mean? It's y equals mx plus b. M is the slope, b is the y-intercept, and that's where it gets the name from, slope-intercept form. Okay, and if you notice, this is the equal sign and y it's on the left. However, this equation is not in that form. We need to change it to that form so that we can graph it directly. What form is this in? It's in standard form. And standard form is when you have ax plus by equals c. If you notice, the x and the y term is before the equal sign. Okay, so in here you only have, to the left, it's y isolated. In here you have x and y. Both terms are on this side of the equal sign. So, to be able to change it from standard form to slope-intercept form, this is what we're going to do. We do the division on the equal sign. To leave y by itself, we're going to get rid of the x term. So if we're subtracting 2x, the opposite is to add 2x. This cancels, and we get y equals, these two are not like terms. So they are not the same because this has a variable and this is a constant number. So we're going to put 2x plus 3. Okay, so that's the process to make it, or manipulate the equation to make it into slope-intercept. Now that it's in slope-intercept, we know that this is the rise and we need the run, so we put it over 1. This is the initial point, which is my first point, which is the y-intercept. The first point. And it's always on y, okay? That's why it's the y-intercept. This is the rise and the run. So rise, that's why I put a sun, because sunrise, and the run. So this is positive, it's up, and this is positive, is to the right. Up and to the right, up and to the right. So first point, it's on 3. So remember, it's on y, so 1, 2, 3, that's my first point. My rise is positive 2, so from that point I count 1, 2, and then the run is 1. Since it's positive, it goes to the right. We can repeat the slope so that you have a more accurate line. So 1, 2, 1. 1, 2, 1. Okay, and that's how you graph using the slope-intercept. But first you have to manipulate. Notice how this is like 2 squares across, 2 squares. So I'm trying to align it so that on the other side I also get kind of like that pattern. 2, 2, 2. So somewhere in here, making sure I don't lose those. And so my line is gonna be somewhere like that. I put the arrows, and that's how I graph, by first manipulating the equation. Okay, let's do another example. If you need, you can always come back. Okay, so again, I make the division. I need to have y by itself. The first, before I cancel the 2, I have to cancel the x term. Oops, sorry. Sorry about that. Again, I have the division. I want to leave y by itself, but I cannot get rid of these 2 first. I have to get rid of whatever is being added or subtracted. So I'm going to subtract 4x from both sides. This cancels. And I have 2y on this side. This is the biggest mistake that I've seen in this case, where people will subtract 16 minus 4x equals 12x. Remember, this is a constant number. This is a variable term. They cannot combine. They're not like terms. So I'm just going to write both of them. Negative 4x and then plus 16. Now, in the previous step, we didn't do anything else because y was by itself already. But in here, y is multiplying with 2. We still have to get rid of that. If we're multiplying by 2, the opposite is to divide. And we're going to divide both sides. Okay? In here, I only have y by itself. In here, we have 2 different terms being divided by the 2. Anytime you have a plus or a minus in the middle of 2 terms, then you have to kind of divide each term by the denominator. So first this and then this. I think you might remember this from module G. So negative divided by positive, negative. 4 divided by 2, 2. And then you just bring the x. Positive divided by positive, positive. 16 divided by 2, 8. And this doesn't have any x or variables, so we just leave it like that. Now we're ready to graph. Remember that we have the initial point. The slope should be rise and run. We don't have the run, we put it over 1. Okay, the run is 1. And again, this is my first point. It's an 8. 1, 2, 3, 4, 5, 6, 7, 8. My rise is negative. So that means that it's going to go down. From that point, it goes down 2 spaces and then 1 to the right because it's positive. Remember that when it's negative, only one of them is negative, not both. Okay, so y, x, okay? So negative 2, 1, negative 2, 1, negative 2, 1, negative 2, 1, negative 2, let me move it up. So negative 2, 1, negative 2, 1. Okay, so that's how it goes. And I just get my straight edge and draw my line. Okay, arrows on both ends to say that the line goes on both directions infinitely. Notice how the slope is negative, my line is negative. Okay, and in the previous one, let me show you, the slope was positive, the line was positive. Okay, let's do one more. Now in here, again, I want to leave y by itself. I draw my line, and I'm going to cancel. If I'm adding x, the opposite is to subtract x on both sides. And this negative belongs to the y, so you can't just get rid of it. You have to keep that negative because it's right next to the y, to the left of y. These are not like terms. Don't say 5 minus x equals 4x, because it's not. 5, it's a constant, so it's by itself, and it's positive. And the negative x, you just bring it down. We can never leave a negative variable, so we're going to divide by negative both sides. Okay, and look here. Negative divided by negative becomes positive y. But in here, we have to do the same thing. Anytime you have a plus or a minus between two terms, you have to divide each one. I call this the pretzel because it looks like a pretzel, where you divide each term by the denominator. So negative x divided by negative 1, it becomes x. Positive 5 divided by negative 1 is negative 5. And we're ready to, we're ready to graph with the slope intercept. I have this intercept, however, I don't have a slope. When there is nothing in here, that means that the coefficient is 1 and you just put it over 1. Okay? Rise is 1, run is 1. I'm gonna not do the sun anymore, but you know that this is up or down because of the sun. This is right or left because of the runner. So negative 5 is the first point, and you have 1, 2, 3, 4, 5 on y, and then 1 up and 1 to the right. 1 up, 1 to the right. 1 up, 1 to the right. 1 positive, 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 positive. Okay, positive 1 goes up, positive 1 goes to the right. And so we're ready to graph. Students ask me, teacher, how many do I need to do? I said, as many as you can. I mean, required is only 2, but sometimes you don't align well, and that's why it's helpful to have as many points as possible with the rise and run, meaning with the slope. Because sometimes you're gonna have 3 terms to the left of the equal sign. And so it's the same thing, it's just that you have to cancel more things. So the first thing that we're going to cancel is the negative 6. If we're subtracting 6, the opposite is to add 6 to both sides. This cancels. I still have negative 2x plus y equals. In here, these are like terms because they are both constant numbers. 0 plus 6, 6. The next step is to get rid of the x term. And so I'm going to add 2x to both sides. This cancels. And so I have y equals. These are not like terms because this does not have a variable. So I'm going to put the 2x first and plus 6 next. Okay, now y is by itself and it's not negative, so we're ready to graph. Remember to put it over 1 for the slope. And so this is 6. 1, 2, 3, 4, 5, 6. That's the first point. Positive 2 over 1. 1, 2, 1. Now remember that we need more dots so that it can be more accurate, but I don't have more space in here. If you want, you can, by changing both signs, you still make it positive, because if you put negative 2 over negative 1, negative divided by negative is positive. So this is the same. So you might go from here, negative 2, negative 1, negative 2, negative 1. So basically you're doing the same pattern. See how it's across 2 squares? You're doing the same, but on this direction, 2 across, 2 across, 2 across. Okay. 2 across, and then 2. And so you're ready to graph your line. Okay, I think I have one more for you. And this is going to be a little bit different, but the same. Okay, so okay, remember we have to get rid of the 3x and the 2, but we first get rid of this. So again, we get rid of negative 3x by adding 3x to both sides. This cancels because minus 3x plus 3x, that's 0. Then you have 2y equals. These are not like terms, so I'm going to write 3x first, minus 4 second. Then this is multiplication. The opposite of multiplying is dividing. Anytime you cancel, you put this line. I don't know if you've noticed that in all the video. Okay, you bring the equal. In here, we have 2 terms, so we're going to divide each term by the 2. But notice how we have 3 divided by 2 cannot be divided. It can be a mixed number, but we're not going to put it as mixed number because we need that rise and run. And I don't know what we would do with a whole number in here. We need it in fraction, even if it's improper fraction. And the negative divided by positive is negative. 4 divided by 2 is 2. And so we're ready to graph. Now we have the rise, we have run. We don't need to put it over 1. Okay? So let me... This is my initial point, y, x. Okay, so y is negative 2, 1, 2. Right there is my first point. Then y, again, is 1, 2, 3. And then my x is 1, 2. The change on x. Again, 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. Okay, and you can do, if you notice, 3 up, 2 to the right, is the opposite will be 3 down, 2 to the left. Now instead of right, to the left. So again, if you want to do more points on the other side, all you have to do is the opposite. Instead of up, down. Instead of right, left. Okay? And that's the line. Okay, so that's it for today. Now you can go ahead and work on page 11. So have fun. And remember to love math because math loves you.